Maria, which do you think is the most sensitive, your eyes or your ears?
Well, I can't really compare them because they're two different things.
Like apples and oranges, is the
Yes.
saying. Well, but within the area of sound, which is more sensitive, and comparing your ear listening to sound and your eyes looking at light, which do you think is the most sensitive?
I think my eyes.
Why?
Because I see many different colors more than I hear different sounds.
Well, you may be surprised because you and I are going to see if we can find out which is the most sensitive. In order to do that, we're going to use the colors of the spectrum that artists have devised. They've taken all the colors and broken them down into various shades. Here are sheets of paper that are the samples that artists can order. They go all the way from yellow through various shades of various colors, all the way down to white and gray and so forth. I have taken the blue ones out, 18 of the blue ones out of this. There are 220 here altogether. I've taken 18 of them out, and here is an extra one. What I'd like you to do is take that one and look down here on the floor. I have those 18 colors.
Yes.
I'd like you to match. You're going to have to use your eyes now to match the color with that with one of those.
All right. This bottom row is too, like, these colors are too dark. It has sort of a purplish color to it. And then this row looks like the colors are very close to this one. And this row, the shades have a bit of green in it, and it doesn't match. So I'm going to stick with the middle row.
All right.
These are still a bit too dark. So these look like quite the same, and these look maybe a bit too light. So I'm going to stick with the middle ones.
Okay.
I think this one still looks a bit too dark to me. I think it's this one.
Okay. Now, artists, you can't say that's a bluish something or other, so they actually put numbers on each one of these colors so they can refer to it by number. Here's the color I gave you. Turn over that one that you chose, right?
6347.
Right. Now turn over the next one, over on that side.
6349.
So you were just one off in a
Yes.
total of 220 colors. So here. Now write down on the pad here, 1 in 220. That sort of gives us an idea of the sensitivity of your eyes, right, in choosing a color. Okay, take the pad over here. Let's go check your ears. Now, see this equipment, Maria? With it, we're going to find out how sensitive your ears are. First, I want to turn them on. And when you throw that switch down like that, you hear that sound?
Yes.
Okay, now open the switch. Okay, now throw it in the other direction. First of all, wait a minute. You were listening to this power supply and this frequency generator and this speaker. Okay, now throw it the other way. Now you're hearing this one, and I'm going to change it so it's like that. Okay, now open it again. What I'd like you to do is to move that dial until both of the sounds are exactly the same. Just like you did with the colors over there, only you're now going to do it with sound.
Okay.
Okay? Leave that one alone, okay? What's the matter with that?
It was too high.
Too
so
high,
I'm gonna... Still too high. Still too high. Okay, I think right there.
Now, in order to find out how close you are, I will turn this on like this and put this little jumper on, and we'll hear both of the sounds at the same time. And a very interesting phenomena occurs. You hear it getting louder and softer?
Yes.
Just a little bit? That's what's known as beats. And you're within, how many of those in a second do you hear? In other words, count 1 second, and how many times does it go up and down? About once?
Once, yes.
In fact, remember, once, and I'm going to change a little bit, you'll hear the difference. Now you hear it about 4 or 5 times. Now move that down so you get rid of them so there's no beats at all. Two, no, go back up the other way. Keep going more. There's about 2 or 3. And you got it just one away. Now what that means is that you were within one frequency in a total range of about 20,000, because let's assume that your ear can hear frequencies down about 50, all the way up to 20,000. So let's assume the total range is 20,000, and you were able to determine one frequency in 20,000. Do you know what to write there now?
Yes.
So which is more sensitive in its sphere, your eyes or your ears?
Your ears.
Well, you really should think of it in another way. Your eyes are very sensitive, and you can see all those colors all the time. But if you put all those frequencies together, you would see just a jumbled mess, right, in color?
Yes.
But when you think about your ears, you're listening to a symphony orchestra. You hear the bass fiddle way down here and the piccolo's way up there. Not only the basic frequencies, but all the little sounds that surround them that make you know it's a bass fiddle and a piccolo. Yes. So you're hearing all of those frequencies all at the same time, and your ear is sensitive enough to be able to pick out every single one of those. So both organs are very sensitive, but most people don't realize their ears are much more sensitive than they thought.
Yeah.
The light in the sky doesn't look like a neon sign, but the principle is the same. Energy from a source, electricity in a sign, and here from the sun excites molecules. In a sign, they're molecules of neon gas. In the sky, they're molecules of gases in the air. The excited neon gas emits light and makes the sign glow. The excited molecules of gases near the Earth's poles produce the curtains of color in the sky called the aurora borealis, or northern lights. Laura Lee, do you know what the word osmosis means?
No.
How could you find out?
Probably in a dictionary or an encyclopedia.
You got them both?
Yep.
Okay. It's spelled O-S-M-O-S-I-S, osmosis.
Okay.
And the reason I want you to find out what it means is because you're going to be doing some experiments with osmosis. One of the things you're going to do is pour vinegar over eggs. Go ahead, try it. Okay.
There's little bubbles coming off of it.
Little tiny bubbles. That's because the vinegar is reacting with the calcium in the egg, and eventually will dissolve the shell away, and you'll have a shellless egg.
No way! It'll fall apart.
No, it won't, because inside there's a little membrane that'll hold it all together. And what you're going to do then is put the eggs, after you've taken the shells off, in salt water, which is used with distilled water. And of course, you're going to need a whole bunch of eggs. And you, I think, will be surprised to find that the eggs, or some of them at least, will get bigger.
Bigger?
Yeah.
Whoa.
Okay. It's kind of a fun experiment. So here are all the instructions.
Okay.
Okay. And then you put all the stuff on here and go ahead and take it home, okay? Then I want you to give me a full report on what happened when you experimented with osmosis.
Okay, thank you.
You're welcome. You can see why I call this a propeller cart.
Yes.
Because it has a propeller there, run by a motor, connected to a bunch of batteries, and it's on some roller skate wheels so it can move. Now, I'll turn it on and let it run across the desk here, and I want you to explain why it does what it does. Why did it go there?
Well, I think that because it's going around, that it's making air or something, and then the air goes back and pushes it forward.
Well, it's going that way, so something's pushing it that way, right? Well, the explanation is a little more complicated than that. It has to do with this is a propeller, and a propeller is an airfoil. So as it spins around, air speeds up over here, lowering the pressure right here. So outside air pressure can push here. And that's what makes it go like that. Now I have a little puzzle for you. Here's a piece of cardboard that fits right on the back here like that. When I turn it on, what do you think will happen?
Well, I think it won't move because when this air is making it go forward,
Now,
there's...
wait a minute. You could, you know, if it's true, if the air coming in here were pushing here, but the outside air pressure can get in over here. But think about this. While it is true that it would tend to be pushed like this, the air that's being pushed by the propeller is hitting here.
So it can't move anywhere.
So there's an equal and opposite reaction, and in that case, it's not going to go anywhere. That's my explanation. Let's see if I'm correct this time. When I let go, it should not move. It's free to move, you see. Okay. Doesn't move. Now, half the size of the first one, right?
Right. So, but I think that one, because there's room here for the air to push it that way and the air to come out from the propellers, that it
So
will
some
move.
of the air that's going this way is now going to be able to go by, so
Right.
it won't be equal and opposite. So what do you think will happen?
It will go not as fast as it would if there wasn't any cardboard here, except half as fast.
Well, partly, anyway. Are you ready? You're all right. Now, a tricky one. About the same size as this, maybe, and the same size as that, but with a hole in it. Predict.
Well, I think that it will go about as fast as the one that was only half the size of the full-sized cardboard, and I think it will still go the
Slowly?
same. Slowly, yeah.
All right, let's see if you're correct. Sure enough. Who was your science teacher last year?
Mr. and Garrow.
Oh. Or would you tell him that you did a very good job when I tested you on the propeller cart?
Okay. Osmosis is the tendency of a fluid of lower concentration
Those are the red marbles over here.
to pass through a semi-permeable membrane
That's this plastic thing with the holes in the bottom through which the red balls can go through, but the white ones can't.
into a solution of higher concentration.
That's the white balls on this side. So when these vibrate around, if they would naturally, the water can only go through that way, right?
Right.
To make that less dense. Now, what's that got to do with your eggs?
Well, first of all, I put my eggs in vinegar to dissolve my shells, and they did. And then I put these ones in distilled and salt and these ones in distilled. This is after 2 days, this is after 4 days, and this was after 6 days.
Okay, now what happened?
After 6 days, the ones in distilled and salt got smaller and the ones in distilled got bigger.
Why?
Well, the thing inside this egg is more dense than the stuff that was outside.
Distilled water.
Right. And
So what happened?
the distilled water would go in to make it bigger.
Right.
Whereas with this, the stuff that was outside distilled and salt is more dense, so the stuff inside would come out to make it smaller.
To make it smaller, yeah.
Right.
Now, what would happen if you went 8 days, 10 days, 12, and so on, and kept going?
These ones would get smaller and these ones would get bigger.
Now, why do you think I wanted you to do this experiment with osmosis? What did you
Well-
find out when you read about it?
Well, osmosis sort of helps the cells to pass liquid to each other.
Yeah, cells. You
Right.
mean including cells inside you, right?
Right.
Yeah, that's, in fact, this is one of the methods whereby food goes into your cells and is distributed throughout your body. A very important concept. Osmosis, which is what?
Osmosis is the tendency of a liquid of a lower concentration to pass through a semi-permeable membrane into a liquid of higher concentration.
Very good indeed. Giselle, I assume you've had some chemistry in school,
Yeah, kind
but
of.
no analytical chemistry.
No, I don't
Well,
think
that's
so.
where a chemist analyzes something in order to find out what's in it. And that's what you're going to do today.
Oh, okay.
See, here are 3 chemicals,
Sodium chloride,
right?
boric acid, And strontium nitrate.
Right. What I'd like you to do is to take one of these clothespins that has a safety pin stuck in the end like that, dip it into this solution, and then bring it up here and hold it in the flame of the blowtorch. And notice the color of the flame.
Okay.
That's what's going to help identify some unknowns later. Are you ready?
Okay.
Okay, put on the safety glasses, and I'll get the blowtorch started, and you dip it in the first solution. You ready?
Yeah. Hey, it's yellow.
Yellow, okay. So put that one down there.
It's green.
Yes, greenish, okay.
Yeah. It's orange.
Sort of orangish red.
Yeah.
Okay, now let me turn the torch off because we'll move these contaminated probes out of the way. And by the way, if you were a real analytical chemist, you'd be using a platinum loop. But I don't have any platinum loops, so we're using safety pins instead. Here are 3 more. And 3 clean probes. And I would like you to tell me which of these 3 is which of these.
Okay.
Okay? How are you going to do it?
Just dip.
Yeah, by the color, right?
Yeah.
All right. First one.
It's yellow. It's red.
It's reddish, right?
Yeah. Or
okay.
orange.
Orangey. So which one is that?
It would be
Over there.
strontium nitrate.
Okay. Next.
This one's yellow.
Yellow. Okay. That goes with the sodium chloride. So guess what the last one's going to be?
It's going to be green, boric acid.
Or green
Yeah.
boric acid. Yeah, very good. So now you can put that. So now you see how you've been an analytical chemist using the flame test to identify 3 unknowns. And chemists use this all the time. So you can tell your teacher you now are an analytical chemist, at least beginning one, okay? Before I cut this all apart, it was in the shape of a T. And what you have to do is to reassemble it, these 4 little pieces, until it looks like a T again. You've seen puzzles like that in books, haven't you?
Yeah.
You have to move them around. Okay, go ahead. See if you can put it in the form of a T.
Okay. This was here.
Okay, you got an angle.
And it's not working. This thing, no.
I assume you know what a T looks like.
Yeah,
Right.
I know what a T looks like.
That does not look like a T to me.
No, it's not working.
Here,
here.
no.
This one.
Here, it looks difficult, but it's not really once you kind of get an idea. Here, put nothing in that right angle right there, and take the smallest one and put it up here. Now, you begin to see across, here's the top of the T. So what do you do with these pieces?
No. Like this?
That's it, exactly.
Oh, and a T.
Right, there's the T. Notice how it's cut sort of at a diagonal like that. Now, if I take it apart, can you quickly put it together again with the... Don't put anything in that. Put the little one up there. That one goes there, and that one goes there.
T.
T.
Got
Now, if I gave you these pieces, who are you going to try it on?
Probably my mom or dad.
Okay, poor lady. Here you go. Good luck. The picture is not running backwards. The man is. Scientists at the University of Toledo have found that exercising only in the forward direction tends to overdevelop the muscles in the back of the legs. Leg muscles come in pairs. One set moves the leg in one direction, and a corresponding set moves the leg in the opposite direction. Effective exercise means using both sets. Walking and running backwards builds up the muscles at the front of the thighs. It's an unusual but beneficial way to exercise the normally neglected set of leg muscles, doing it backwards. Tarek, I want you to snap your fingers right in front of this little plastic cylinder.
Okay.
And then watch what happens on the computer screen up here. Go ahead.
Oh, that's neat.
Yeah,
Holy.
that's a sonogram or a picture of the sound of your finger snap.
Oh.
And scientists use this technique of taking a sound and recording it and being able to spread it out in lots of different ways. For example, this one took 30,000th of a second to go across here.
Yes.
So we really took the sound and spreaded it out quite a bit. Scientists have also used it to identify the voice, for example, of a criminal who calls up on the telephone. They record the voice, of course. Then later on, when they get him into court, they can compare his voice. And even though it was disguised and over the telephone, there are characteristics of your voice that are very,
Yes,
well, you sort of hear it a little bit, but
Yes.
it's much more plain when you spread it out like that.
Yes.
Other scientists use the same technique to analyze bird songs. And not only do they identify the bird like a cardinal or something, but individual birds have individual calls. And sometimes they use them to attract mates, too.
Yes.
Why don't you do another one? Let me switch it down to the bottom and see if you can compare it. Try again. Try another one. See if you can move it over a little ways. Oh, too much that way. One more. There you go. Now, you see how
Yes.
very alike they are? You know, take a look at it. Where do you see the similarity between Tariq's finger snap?
Well, right about here.
Here?
Yes, it's the same. And then it kind of tails away.
Well,
similar.
notice but this high point right after this. See, it's the same right in here?
Yes.
Here's one I did earlier. Take a look at mine and see how different it is.
Well, yours are more dipped at the starting.
It has a dip right in here, right? Yeah.
Yes, and they have a lot of chords.
Yeah. So anyway, I'll make a print of this later, and you can take it home and show everybody what your finger snap looked like when you make it into a sonogram.
Yeah, this is great.
Yeah. Thank you. See, I have 500 written on this cup.
Yes.
That's because it holds 500 milliliters. You know what they are?
Yeah, they're thousandths of a liter or cc.
Same as the cc, right?
Right.
Okay. And because I have 300 written on this one, you can imagine that holds
300 milliliters.
What I'd like you to do is, using only those two cups, hand me one that has 400 milliliters in it.
400? I don't think that's possible.
Oh, yes, it is. May I make a suggestion?
Sure.
Fill the small one first.
Okay. That will be 300 milliliters.
All right. Now pour the small one into the big one.
Okay.
Fill the small one again.
Okay. There's another 300.
Pour that one into the big one.
But it won't fit
Why not?
because this one only holds 500 milliliters, and when I pour this one in again, it'll be 600 milliliters.
Okay, so fill it up anyway.
Okay. And that when you take 500 away from 600, you're left with the extra 100.
Okay, now do you know what to do?
Yes.
What?
You pour this one back in here.
All right.
Then I pour the 100 milliliters into this one,
All right.
which will be 100
Okay.
plus 300 milliliters will be 400 milliliters. Here's your 400 milliliters.
Okay, thank you. This is sort of a problem in logic, isn't it?
Right.
I mean, it didn't look like it could possibly get 400 when you only have a 300 and 500,
Right.
but you did. So who would you like to try this on?
Probably my dad.
Okay. All you really need are the two cups. Good luck. Hope you fool them.
Thank you.